Hi everyone. This is just a quick video to show you what I'm working on and talk a little bit about wood movement and also to try out a new camera. So if you're seeing this, it means the camera worked and I was able to edit everything from it properly, and you'll get to see a little bit here about wood movement. So what I've got in front of me are a bunch of chair parts that have been roughed out to some extent. Some are almost finished, like these back legs are very nearly complete. They just get a little more final shaping. Some are quite rough, like these front rails, and others, like these side and back rails and front legs, are in kind of an in-between place. And whenever you're working with wood, you have to remember that wood is not plastic, which is to say that wood is not uniform. Any piece of wood is a composite of different types of fibers and proteins and sugars that create this matrix. And when that is exposed to changing temperature and humidity, it's going to move and shift. And similarly, when this tree is alive and growing, it's under strain, whether that's the weight of the branches or that it's leaning or that there's a prevailing wind. The tree responds to that and it grows the tissue differently depending on what those stresses are. And so when you start to cut material out of a tree, it begins to react. So if the tree had to fight a lean on a hill, it means that it's much denser below than above. And every time you cut into that, it's going to spring farther and farther toward what used to be the uphill side of the tree. And that's always true. Every piece of wood you ever work with is going to have tension in it. Wood that's been properly milled and dried and has come from a good tree will have less, but all wood moves. And so we sneak up on our final part sizes. If we just go directly from the rough stock, which for these chairs was all 8/4 ash, and we just immediately go from this down to a 1-inch piece for the chair's rails, it's going to move all over because you're releasing so much stress in this wood. And so in order to combat that, what we do is we take very, very small bits off at a time, relatively speaking, small to us, large to the tree in terms of internal tension, and then we allow it to normalize, which is what's happening here. So each of these parts has gone through a couple stages now, where first I use either a joiner plane or a jointer and flatten one side. Typically the side that is concave is easier to flatten. And then you use that flat side as a reference to plane it. And I usually take about a 1/16 of an inch off of each face before bringing it back over here to rest and giving it, stickering it to give it good air exposure so that these rough parts can move as much as they want to, as much as they need to relieve those stresses. And by sneaking up on it like that, you are compensating a little bit at a time for the some stresses in that wood, so that in theory, by the time you get to your final part size, you've already compensated for that stress and it's going to remain much, much more stable. So I bring all this stuff down until it's a little less than 1/8 of an inch bigger than the finished part before finally jointing it and planing it to the final sizes. And that's just a simple thing you can do to ensure that your projects don't pull themselves apart because of the movement of the wood. Gold standard is take no more than 1/8 of an inch off at a time and then let it rest for at least 24 hours, and you'll wind up with a really nice stable part when you're finished. So I hope you learned something, and I hope you're doing well out there. Just wanted to give you a quick update from the Perseverance Works, where right now we're building chairs. Thank you.